right? The lesson is loading now. We're moving into finding the area of trapezoids.
How can you find the areas of special quadrilaterals? Think about this question during the lesson. The pasture is in the shape of a trapezoid. A trapezoid is a quadrilateral that has only one pair of opposite sides that are parallel. What is the area of the pasture?
Let's find out.
Let's find out.
What do you know about the top and bottom sides of the trapezoid?
So highlighted in yellow here. We know that this one here at the bottom is 18 yards, and this one here at the top is 10 yards. That's what we know. There are different sides, so this shape is not a rectangle. When two of the sides are parallel and two are not, we call that shape a trapezoid. Okay?
The top and bottom sides of the trapezoid are parallel. You can use structure by decomposing the trapezoid into a rectangle and triangles.
Why did they decompose our farm animals? I want them back.
How can you decompose this trapezoid into a rectangle and two triangles?
Let's talk about that word decompose. I think maybe the best way of thinking about it is thinking about the word compose, right? If you're a music person, music is composed, it's put together, right? So composing something, in one sense, you could think of it as putting things together. So decomposing something, we talk about in math as it's breaking things apart, kind of like what we saw with the parallelogram and the triangle. When they broke the parallelogram into two separate triangles, you could say that that was decomposed. So we're going to be doing the same thing here with this trapezoid. We're going to decompose this trapezoid into different shapes, right? So here they tell us into a rectangle and two triangles.
Draw two line segments from the top vertices that are perpendicular to the base.
And there's that word perpendicular again, right? Perpendicular lines are two lines that form an angle, and that angle has to be exactly 90 degrees. Anytime you see that little box written at an angle, that tells you that that angle is 90 degrees.
Find the length of any missing base or height. How can you find the base of the triangle on the right?
So this triangle here is what they're talking about, right? So let me choose a blue. They're looking at this triangle. I'm not drawing it perfectly, but that's the triangle they're asking us about. They want to know this length. How far is this distance? Well, if this is a perpendicular line and this is a perpendicular line, from here to here is 4, according to this. And then from here to here is 18. Actually, the whole thing is 18, right? From here to here is 18. So what does this have to be so that it all equals 18, right? We know this distance is 10, so we know this distance is 10. So what does this have to be in order for all three sections to equal that 18? So it has to be 4, right? 4 plus 10 is 14, plus 4 more is that 18 yards, the whole distance. I'm sure they're going to probably tell you it, probably do a better job than I did, but let's see what they say.
Subtract the sum of 10 yards and 4 yards from 18 yards. Find the area of each shape. What is the area of each triangle?
Notice the triangles are exactly
Select your
the
answer.
same. Triangles are exactly the same, so that's why they're saying to find the area of each, because they're the same thing, right? So we know the area of a triangle is 1/2 the base times the height. We might be able to do that mentally, but let's kind of write it out again. Area equals 1/2 the base times the height. This is for triangles. So 1/2 base of our triangle is 4, and the height of our triangle is 10. So 1/2 of 4 is 2, and 2 times 10 is 20. So we have 20 yards squared. Uh-oh. 1/2 the base. What is, find the area of each shape? I did 1/2 of 4 is 2. Oh, the height is not 10, the height is 12. There we go. So the height is 12. 1/2 of 4 is 2, and then 2 times 12 is 24. Whew!
The area of each triangle is 24 square yards. Find the area of each shape as shown. Add the areas of the triangles and the rectangle. The area of the pasture is 168 square yards.
So right here, we have one triangle, and then the second triangle, right? Triangle on the left, triangle on the right, and then the area of the rectangle in the middle. Add all three together, we get 168.
Yards.
Drag the triangles apart to see how the area of the trapezoid is the same as the sum of the area of the two triangles. So I guess this one in red is the same as this one, and this one in red is the same as this one. Okay, kind of makes sense.
Now you know how you can find the areas of special quadrilaterals.
All right, so the questions that go with example 1 are on pages 417, 418, numbers 7, 11, 15, and 16. I'll write those here. All right, here we go. Page 417, 418, number 7, 11, 15, and 16. Raise your hand if you need some help. Remember, if you're interested, we have peer tutoring available as well.